Lord from Metaio, who's going to be talking about 3D cameras and AR. So, Trak, take it away.
Hi. Uh-oh. Am I too tall for this thing?
Yeah, into the microphone, man.
Yeah, well. Hi, I'm Trak Lord. I am the head of marketing for Metaio. You guys, I'm going to try and keep this quick because at my calculation, I got about 30 seconds per slide with this new time agenda. So if you haven't stopped by, we're, of course, a silver sponsor here at AWE. We have a great big booth down on the expo floor where you can actually see a lot of this 3D technology that I'll be talking about today. If you haven't heard about Metaio before, one of the longest-running computer vision professional companies. Been around for about 12 years. We have all sorts of cool software that I'm not going to worry about you today. We've done a bunch of cool projects, and the nice thing about Metaio is that we're around 75% R&D. So for all intents and purposes, we really are a technology company. We're constantly in the labs working to improve not only our computer vision technology, but sort of the overall possibilities in the industry and the space. One of the things that we really care about, and this is echoes a little bit of what Neil was talking about when we talk about the power consumption and my favorite Neil Trevitism, which is the exploding iPhone or smartphone because of the CPU overload. We really, oh, thank you, water. We really, for augmented reality especially, we see it as an always-on, always augmented kind of thing. Because there's only so far that the industry can really go with these, with any kind of like one-off application. You really need that compelling content and those compelling experiences that not only keep the user coming back, but are possible to use on a daily basis, on a regular basis. And that's sort of where we sort of approach augmented reality currently from a use case standpoint, from form factors, especially with wearable computing, and the enabling technology. Part of the reason that we look into that is because we see augmented reality and to some degree even computer vision separated in this kind of, or broken down in this kind of schematic where you have micro cases of augmented reality, sort of like the image and the object recognition and the sort of singular use cases, and then you have the kind of macro when you're actually looking at entire environments and entire operations. And we look at the fact that 3D and other enabling technologies can really help power these experiences across the board. To give you an idea, we essentially try to serve every aspect of the augmented reality in our R&D efforts, from the actual hardware that would go in to accelerate the technology, all the way to that middleware and software that will power and ensure the good user experience for the consumers or the developers. So, we're here today talking about 3D depth and 3D cameras. Maybe get a show of hands. Who here considers themselves a non-technical person? Hey, you and me both, buddy. All right. So that's good to know. So in that case, this is not going to be news to you all, but if you look at the recent advances in 3D imaging, there we go. If you look at the recent advances in 3D imaging, you see things like 3D printing, the ability to create 3D scans of, for instance, brains, the ability to scan objects into reality or 3D format, and of course the augmented reality side, which is the 3D object and recognition. And besides from the computer vision researchers in the labs, you see a lot of very public announcements recently. Throughout the beginning of the year, Intel announcing their RealSense platform and talking about the embedding of actual 3D cameras, which, as we know from the Kinect, used to be quite large and not very mobile. So you have a real initiative, not just Intel, but of course sort of the other startups that are now making 3D scanners and trying to get them into devices and into very friendly use cases. And of course we all remember when Apple decided to make a very awesome purchase, and they purchased PrimeSense. And you got to wonder, from a company that really hasn't done a lot with camera technology, suddenly coming out of nowhere and purchasing one of the major players. And that's not the end of it as well. You have incredible companies like SoftKinetic, and a lot of these companies, NVIDIA, SoftKinetic, Occipital, they're here. They're here at this conference, and they're here looking at what the future of 3D interaction is going to be. And that basically ends the non-technical portion of this presentation. So basically, we're starting with 3D, right? So walk you through real quick. So the first thing that you want from 3D, right, is the ability to very accurately map your surroundings. If you're going to be using depth, you want it to be accurate and, above all, precise. From there on, you're talking about actually creating a 3D model of a physical space. which of course goes into making sure that that accuracy is maintained in object or in the scale of the shape. And of course, what would be really nice is occlusion handling. The ability to actually place objects in the real world that behave naturally. If you have consistent content that's always in the foreground, you're never going to really be able to go beyond that, right? You need people to really understand and interact in 3D. And of course, also the content generation of CAD models and other 3D objects that you can use in this environment. Unfortunately, that is pretty taxing on any normal device. You're talking about a huge amount of memory usage, a huge amount of processing, a really, really hot and potentially flammable CPU without acceleration. So these are things that we really find as challenges to basically, we can get in there and change it. This is a slide on projective depth tracking. I don't know why that was in there. So the way that we're sort of approaching it in the same sort of genre as those micro and macro ARs, we have technologies for facial reconstruction, which, of course, in the spirit of time, I'm going to skip the video because you can actually see this demo live at our booth downstairs in the expo. And of course, these challenges, as we're talking about, user experience, right? No one's going to pick this up, continue to use it unless it's natural and intuitive. The things that you have to cope with, one of the things we talk about is noise. And myself being in marketing, I understand that term very well. But when we talk about in terms of 3D, we're talking about all of the information that's unimportant to the experience. And right now, it's definitely a challenge to really lock that down. You also have this fusion of 2D and 3D information, not just from a computer vision standpoint when you're utilizing both depth and 2D planar tracking, but also being able to merge that content and make sure that that's a natural experience. The architectures, echoing once again Neil, talking about how this really has to be changed in order to be optimized. And actually, we're pretty excited about OpenVX as well and the ability to actually talk to hardware. But as I keep repeating in the flammable iPhone, that power consumption, and that goes back to always on, right? In order to have always on experiences, you have to have a battery that's going to last more than 15 minutes. Especially with wearable computing, if you're going to wear something on your face, you want to be taking it off every couple hours to charge it again. And of course, we're talking about then actual embedded systems, parallel processing, things that really haven't happened yet but are in the works and are extremely important for this technology to really progress and succeed. On that same note. And then, of course, combining these sorts of tracking and reconstruction technologies that will really take advantage of scalable and accelerated hardware. And to that effect, we've been very heavily researching hardware, especially silicon acceleration. And that's why a couple of years ago, we released this thing called, or announced this thing called, that we call the Augmented Reality Engine, the AR engine for short. And it's a piece of silicon hardware IP that would ideally sit on an SoC and accelerate computer vision functions. Because we know, from a software perspective, that every time you're doing computer vision action, you have the feature extraction, you have the image recognition, you have all these tasks, and they're happening at the same level as the CPU. And in order to basically stop that from happening, we develop an acceleration chip that really acts as a funnel, and it takes all of those actions. Because it doesn't matter if you're looking at a 3D space, an image, a magazine, a newspaper, a complex industrial object, the processes are always the same. And if we can accelerate that, in our initial tests on FPGA, we've actually been able to increase initialization by about 6,000%. So we're talking about factors of 2 or 3, we're talking about a factor of 60, just from hardware acceleration. And to that effect, reducing battery consumption as a result of augmented reality experiences by up to 85%. So once again, really ensuring the length of these things. Of course, smooth user experience, as I discussed, lower power consumption, and of course, really utilizing that parallel processing and looking up to basically allow the CPU and the GPU to do what they're supposed to do, which is run your phone and power the more important aspects of your phone, not having to do it all at the same time. So yeah, that's basically where Metaio stands on 3D depth. A couple things before I finish. Speaking of 3D, we're actually giving away an occipital structure. Our friends at Occipital have been nice enough to basically give us this structure to give to the community. So stop by the booth. Unfortunately, it's around 5 p.m., so you're going to have to run because the giveaway is today. But feel free to go by, and I'm sure they'll give you guys a last chance if you haven't already entered. We're also giving away a pair of physics glasses because we just feel like the augmented reality Santa Claus today. Unfortunately, that giveaway also ends today. So please go to that website, check it out if you want to, be in the running for that. Great device, the M100. And then, of course, when we're talking about other sensors, I don't have a lot of time to go into this right now, but if you guys haven't heard, we announced this thermal touch prototype as a sort of a future user interface for wearable computing. Essentially just combines a normal light-sensitive camera with thermal imaging to register a heat signature. So when you touch something, that minute, to the thermal camera, white-hot fingerprint acts as kind of an anchor for an augmented reality tracking experience. So we can actually design new interactions, and it's on display at the booth. You can go check out the demo. It's probably the only time you're going to be able to see it. It's highly prototypical. It definitely does not work very well, but it's in stages, and we see it as a very potential aspect, especially when you consider device manufacturers that are getting more and more interested in other sensors. So it's really just another dot on that array of cameras that may live in a future device. But especially for wearable computing, the possibility to turn everything into a touch screen, like no necessarily, you don't have to be stuck to voice, you don't have to be stuck to a companion device, you don't have to be stuck to shoulder-mounted projectors. This basically sort of, I believe, frees up a lot of the possibility of future interfaces. And as Neil mentioned, ISMAR, it's a really cool conference. If you haven't already been to it, it's in Munich this year, which of course is our hometown, not my hometown. I'm definitely not from Munich, but it'll be a good conference, and it's very research heavy. You enjoy it. We also Metaio hosts an annual augmented reality computer vision conference as well, conveniently also located in Munich. So if you guys want more information on that, feel free to go to our website, InsideAR2014.com. Hopefully we'll see you there. And that's it. Thank you guys very much. Please let me know if you have any questions.
And does anyone have any questions for Trak? Looks like we have one, so I'd ask the next speaker to get set up.
I was just curious when we might expect to see the acceleration engine chips available.
That's a very good question, and one that I really can't answer. I can't tell you that, and one of the reasons I can't answer that is because the actual life of SoCs and that cycle of actual development is way beyond my comprehension. So I feel that even if someone really benevolent today said, hey, I really want that chip in every phone that my company makes, I think you'd still be looking about a year or two at least before that really becomes in mass production. That would be my guess. But it's less about necessarily getting it in the phones than I think for us it's been very positive as a way to really start the conversation with OEMs and people that are interested in computer vision. A lot of times I feel like the conversation ends up leading back to software optimization. But that, when you start with that, when you say we can increase initialization speeds in computer vision by a factor of 60 and we can reduce battery consumption, that's a good place to start for that conversation. We did, of course, announce that we were going to be integrated into ST Ericsson's Novathor platform. But of course, unfortunately, 3 weeks later, ST Ericsson ceased to exist, which we had no control over. But they were going to do it had they continued the joint venture.
Okay, so any other questions? No? Well, thank you, Mr. Trak.
Thank you guys very much. Appreciate it.